ladies and gentlemen. My name is Mahalingam. It's an absolute pleasure to be here at API Days. And first of all, thank you, API Days, for inviting me to speak here. My name is Mahalingam, and I'm going to speak on 1 to millions opportunities and challenges in scaling APIs. Just before we dive into the session, let's have a quick look at who am I. I'm a senior partner solution architect within the GSI Partners organization at Amazon Web Services. I'm based in London, and I've got about 25 years of IT experience, and 20 of which are in financial services in the UK. I'm a Cub Scouts leader with a Scouts group in the Kent County, an ardent Arsenal fan, and I'm married with a 15-year-old son. If you're interested in connecting with me on LinkedIn, you'll see the slide link over there, along with the QR code. Okay, so getting to the meat of the whole session. So in this session, you're going to look at introduction. We're kind of done with it. 1 to millions opportunities and challenges in scaling APIs, which is the real meat of the session. And we'll talk about what's an API, what do you mean by API scaling, opportunities in scaling APIs, challenges in scaling APIs, scalability strategies, customer case studies, best practices, and then conclusion, where we just try to recap what I covered in this session. Okay. So first and foremost, what's an API? The API has been from the beginning of computers in some way, shape, or form, and it really became ubiquitous with the emergence of internet. Okay. And I'm sure most of you would know what is an API, but if I had to explain it to, say, a 5-year-old kid or my granny Gloria, I would say, something like this, right? So if you go into a warehouse, a DIY warehouse, for example, and if you want to buy something, a list of products, for example, without a catalog or any sort of shopping guide, you'll be really lost. And the manager or the staff there would give you a product catalog, which you would use to identify where the products are, as in which aisle and which shelf. That helps you to identify where the products are so you can do your shopping yourself without getting any special assistance or help from anyone, okay? And then you end up going back home as a happy shopper. So in this case, a product catalog is a key enabler for a good shopping experience. In a very similar fashion, you've got enterprise data spread across in different data stores, perhaps in silos, okay? So without API kind of a service, if you just want to explore and find data yourself, you're going to struggle. You won't know where to start. And APIs on top of it is a key enabler for getting access to the enterprise data, and in some cases, even getting a single pane of glass view of your business, of your customer, of your infrastructure, whatever is your area of focus. And that goes for users, applications, and any other systems you may have. Okay, so essentially, whatever task a product catalog is doing in a warehouse is very similar APIs are doing. Okay. So we saw what's an API. So let's look at the API market size and what's the forecast for the future. The API market size, you can't ignore them, because as of today, in 2023, it's worth around 6.77 billion US dollars. And it's going to go to around 52 billion US dollars by 2030. In 2032, it is expected to be just short of $100 billion. So it's a very significant and a very lucrative market to be in, the API market, okay? So how is the API landscape evolving, actually? See, APIs, right? They are very key to any company. So it can be a bank, a non-banking entity, a retail fashion organization, a retail FMCG company, telecom organization, any organization, right? And the products and the solutions landscape is constantly changing and evolving. This puts pressure on the companies to evolve and innovate, right? And in this kind of situation, most companies look at APIs to raise the bar and keep up to the customer expectations. Okay. So the first and foremost you look at is the way what's driving the API evolution is growth. So recession and pandemics, they have caused the global business outlook to take a dip, though momentarily. However, now that we are bouncing back, revenues and volumes of products and services are coming back to pre-pandemic levels, if not more. So the API revenue and the models volumes, they are returning back to the pre-pandemic levels, and they require the ability to scale to meet the ever increasing demand from the customers and consumers. The next evolving driver between the API evolution is digitization. The pandemic has accelerated quite a few digital transformation initiatives in all kinds of companies. And this has caused the launch of new services, new products, new partnerships to offer solutions in real time for customers. Okay. Let's look at another side of it, so which is technology modernization. In companies, big companies, particularly these days, there are very active conversations around technology modernization. And this requires the companies to upgrade or, in some cases, retool their infrastructure. And when it comes to integration, the new innovations and business ideas drive new levels of integration. So, for example, in financial services, open banking, banking as a service, electronic KYC, crypto, or even CBDC, and other similar use cases, they are accomplished purely via API-based integrations. So hence, that is driving the evolution of APIs. Okay. The next one is, in the traditional approach, you just had simple client and a server, and that meant the realm of APIs for us. But in the new world of APIs today, we see there are new API personas. You've got a creator, you've got a curator, you've got a composer, and you've got a consumer. Let me explain this in a very simple example. So let's say you've got a specialist company specializing in, say, payment services. They would create and offer an API. That could be for a card payment, a bank transfer, or a recurring payments, whatsoever it is, right? So that company or the PSP is now called the creator of the APIs. Curator next curates the APIs and offers it in a marketplace. That could be a banking marketplace, a cloud marketplace, a cloud service provider marketplace, or even any service provider marketplace. Okay. And somebody else might opt to build, let's say, an end-to-end lending workflow, and they need to use such payment APIs. So the lending workflow typically starts with onboarding a customer, pretty much finishing with creation of the loan account and then disbursement of the payment to the customer who requested the loan, right? So for that last part, disbursing of the payment back to the customer, you need a payment API. So the composer is the entity that's building the end-to-end lending workflow here. And through the curator, i.e. marketplaces, they use the payment API created by the creator. And in some cases, what happens is, say, banking as a service, and that kind of an end-to-end workflow is used by somebody else, the end customer or consumer in this case. So hence, the consumer API then consumes the composer API. So hence, you can see the difference between the four personas: creator, curator, consumer, and composer. This is a very interesting aspect here, actually. So back in 2002 in Amazon, Mr. Bezos, the founder of Amazon, he recognized the need of using APIs that would enable the different departments to communicate with each other. And he issued a mandate stating that all the teams should expose their data and functionality through externalized service interfaces. And all the teams must communicate with each other only through these interfaces. I see this as one of the seeds of the foundation, of the principle of APIs. So we saw what's an API. So now let's see what is an API scaling. So API scaling is all about handling spikes and sudden bursts or increases in the API traffic and requests. Specifically, it's the ability of a system to support concurrent API requests coming in and serving them without any significant impact on the performance or the end user experience. Okay. So we saw what's an API, what's API scaling. Now let's look at the next set of topics here, which are opportunities and challenges in scaling APIs. So if you look at the opportunities in scaling APIs, so the first and foremost comes in the form of growth. So the service volumes or the product usage volumes, they have grown over the year and they continue to grow year by year. The companies utilizing the legacy systems are faced with these very same growing volumes passing through their aging infrastructure. And they are faced with a decision to update or upgrade these very legacy systems. So that's an opportunity for getting in APIs, and particularly scalable APIs that we are discussing here. And particularly when it comes to enterprise infrastructures, the service providers or even the end companies that own this infrastructure, they are forced to do annual updates. It can be patching, upgrading, evergreening, whatever you want to call it, right? And that leads to the companies globally making decisions on how to balance the investment dollars. So instead of spending money on innovation and new business ideas, they end up spending this money on upgrading their infrastructure, or what I call as an undifferentiated activity of maintaining the infrastructure. We all know data is a new currency, and data-driven decision making is the new normal. And for growing the utilization of data-driven decision making, APIs do play a very key role. Okay, because of these 4 or 5 aspects, I do think we have a very good opportunity for API. Now let's look at challenges in scaling APIs. So the first and foremost is security. It's estimated the time between 2 cyber attacks is about 39 seconds, according to a survey. Now, more the APIs, then more the attack surface, or the attack surface which is prone for, which is vulnerable for any cyber attacks. More the attack surface, higher is the risk for cyber attacks. So hence it's immensely important to secure the attack surface whilst driving innovation and collaboration in a secure manner. Our CEO, Andy Jassy, he once said, security is job zero at AWS, which means nothing is important than maintaining the highest standards of security. So in scaling APIs, security is one of the first challenges what you face, and it's partly because of increased attack surface. Okay. The second one is the cost implications of increased infrastructure. So particularly when you look at APIs in bigger companies or enterprises, you'll see you may need to manage multiple instances of API gateways. In some cases, forget about multiple instances. Some may even use multiple different kinds of API gateways. I mean products. Okay, and what that leads to is unwieldy expenses on the usual undifferentiated activities I alluded to earlier: maintaining, upgrading, evergreening, all those aspects. Okay, so it's a challenge when it comes to scaling APIs, particularly if you have an on-prem API infrastructure. Scaling becomes a challenge because of the cost implications on the infrastructure management aspects. Then you have the challenge of performance bottlenecks and latency. As the usage goes up, the system should scale out and scale in as per the loads and volumes of your business activity. Particularly in on-prem scenarios, this is quite a common challenge, because when you provision your infrastructure in an on-premise data center, you would provision with a little bit buffer of your peak volumes. And suppose if you get an unexpected spike or a burst in your API usage volumes, then you're constrained by the limits of your on-premise infrastructure. So again, that's the bottleneck I'm talking about. And that could lead to performance degradation or in some cases, availability issues as well. As I alluded to earlier, data-driven decision-making is a new normal. So in a data-driven decision-making scenario, a veracity or the accuracy of the data is very important. And APIs are a key enabler for getting data consistent and synchronized. The more precise the data is, the more better the decisions would be based on those data. So hence, APIs are key enablers for getting the data in a consistent manner and synchronized. And again, as I said earlier, if you want to have a single pane of glass to have a 360-degree view of your customer, business, infrastructure, or whatever is your area of interest, APIs are very important. And again, when it comes to maintenance and monitoring, you again have the complexity of it. So if you have a heterogeneous landscape, then you need to have that many number of tooling for maintenance and monitoring aspects. And depending on the on-premise workload, you'll have the monitoring and the observability challenges, quite often driven by the tooling or lack of tooling, either way, okay? Then we look at scalability strategies, okay? So there are about 5 strategies I discuss here, but there are more, okay? So it's not a definitive list here. So the first one is one of my favorite ones, and it's been there for a very long time. So the load balancing and having distributed systems. This has been around for quite some time, and it works well in an on-premise setting as well. It's basically having multiple instances of your API engine and having a load balancer in front of it. So essentially, the load balancer acts as a traffic cop, directing the traffic of the incoming API request to the specific API instance or instances that can serve the request. One of the key points here is when you have multiple instances of your API, and if you want to achieve the horizontal scaling on the back of a load balancer, the APIs need to be stateless. So it's all the more important that when you build APIs, it has to be a stateless API. The second one, a strategy for scalability, is caching for improved performance. So when it comes to data in any enterprise, some they change less frequently, some change more frequently. So the volatility and the velocity of the data is quite key in deciding which data to be cached and which one to be not. For example, you have the customer master details, right? First name, last name, date of birth, address line 1, address line 2, city, postcode, state, and country. They don't change that often. They do change, I'm not denying that, but they don't change that often. So these could be cached. And of course, what you also need to do is when such data sets, data elements change, you need to have solutions in place so that the cache gets updated with the latest values. Having said that, the caching certainly improves the performance of the application, undoubtedly. The third strategy is microservices. If you have a very legacy traditional monolith, it's very difficult to scale a monolith. The only way to scale the monolith is to have multiple instances of the monolith. So instead, you refactor or break down the monolith into smaller microservices depending on the domain of the service or the functionality of the service. So in a typical digital banking scenario, you can have onboarding microservices, you would have account services, you can have payment services, you can have KYC, fraud checks, and different kinds of microservices. So the idea is to divide and conquer instead of having a one big monolith, which is very difficult to manage. Also, I'm not saying do a big bang and break down your monolith into individual microservices, perhaps taking 6 months or 1 year. I'm not saying that either. So one of the easiest strategies to follow is something called as a strangle the monolith. So you freeze the monolith, don't create any new feature releases in the code base, from the code base of the monolith. Instead, focus your new functional releases on the microservice pattern. And over a period of time, what will happen is you'll have most of your functionality running as microservices. And over a period of time, you'll also see your monolith starts to shrink. So in the ideal or desired target state, you'll see the monolith would be very minimal or would have even disappeared. And in the example I mentioned, onboarding services may not be used that frequently when compared to a payment service. Payment service could be an horizontal service serving different business units in the bank. So when it comes to payment services, they need to scale out and scale in pretty significantly when compared to an onboarding service. And that's what I call a heterogeneous scaling strategy. The next one is horizontal and vertical scaling. It's a very good strategy for scalability. I'll give a simple car analogy to understand these two phrases, horizontal scaling and vertical scaling. Let's say you're going out with your mates, 3 of your mates in a 4-seater car, okay? All of a sudden, 3 more of your mates want to join. What do? You've got 2 paths in front of you. Option 1 is get another 4-seater car in which the 3 new mates can join you, and you go together as a convoy of 2 cars. Or you get a 7-seater, 8-seater, or a 9-seater, some sort of an SUV, and you all travel together. So the option of having a 2-car convoy is horizontal scaling. And having one big SUV where all the mates can travel, that is vertical scaling. Simple as that. Now the last one. So typically in a synchronous API calls, it's blocking, what we call as the server process waits till the process finishes and then you get the response back. If you're experiencing or if you expect very high volumes during your peak periods, you don't want to have restrictions like that. So instead, you go for async processes for handling specifically those kind of bursts using during your peak to peak volumes. And async processes are non-blocking, and typically you'll see the incoming requests, they're queuing up in an input queue or a topic, and then you'll have what we call as a pool of worker nodes, which would start processing the requests from the queue. And because it's a pool of worker nodes, they can run concurrently and you can run multiple tasks at the same time, eventually exhausting the request from the request queue. So these are some good strategies to handle scalability problems in your solution. Now let's look at some customer case studies and best practices. So this one here is one of the one of a good success stories at AWS. So this is a Brazilian bank called as Itaú Unibanco. It's one of the biggest bank in Latin America. Pretty much 1 in 5 payments in Brazil is processed by this bank. So they're more than 60 million customers, and they had some significant challenges like the transactions per second for their on-premise system was ranging from 15 transactions or 50 transactions per second to 1,200 transactions per second. So it's a pretty big range. And equally, the availability requirements for them was around, which was much more than 99.5% percentage of SLA. And that was a bit of a struggle for them to maintain given their previous on-premise solution. And of course, as I said earlier, with an on-premise infrastructure, you hit a threshold and you have the constraint on the scaling aspects. Hence, and there was also a regulatory deadline looming for about 10 months where they have to come up with an instant payment solution. So what they did was they built an instant payment solution named as PIX, P-I-X, PIX, on AWS in only 10 months. And they achieved, on an average, 99.8% SLA, and they got more than 15% average monthly growth in the new stack in terms of the transaction volumes. And a customer onboarding process took a few minutes, that's it. And the deployment time, it took up to only 20 minutes while it used to take a week or something at least. Now the whole thing was realized using serverless and API solution on AWS. So it's quite a success story for one of our customers. The next one is one from the UK. It's called Babylon Health. Babylon Health is a remote GP application or a remote video consulting with a doctor application. They built their omni-channel services using APIs, and that was augmented by AI services as well, AI solution as well. So which meant both their mobile application and the web application were utilizing these APIs, and they're a pretty successful company in the UK. Next one is Axis Bank. It's one of the leading banks in India, and they process about 10 million real-time payments every single day. And they have used a combination of auto-scaling EC2s and Kubernetes services from AWS to realize the innovative banking services that they were aiming for. And again, this is a very good success story from one of the banks in India. The other customers in the UK, I want to just briefly mention, are the Curve Card app. So Curve Card is a payment fintech from the UK that aggregates multiple payment cards into one. And they have leveraged the power of cloud and the power of APIs. And they are a very successful fintech in in the UK. They're one of the leading card aggregators. The second one is another fintech called ClearScore. It's a British fintech that provides credit scores, credit reports, and current account analysis for customers. They managed to roll out their service in a new market in about 3 months and achieving 99.9% SLA and significant operational efficiencies. So again, another customer success story from one of our customers. Before we conclude the session, I just want to leave some of the best practices with you guys. So the first one being design APIs for scalability. The scalability first mindset is key. You got to design much more than your peak loads because you never know what sort of peak volumes you're going to get. So hence, design your APIs with scalability in mind. And doing so would future-proof your design against unexpected volumes in the future. The second one is one of my favorite ones, and I've been telling my teams for the last decade or so, is design for failure. Never be satisfied just by looking at the happy path. The error handling in your APIs have to be watertight. You have to make sure every single error handling is done for the key data elements you're looking for. For instance, let's say you're handling a payment API. So if you don't have the minimum required data elements, you can't go ahead with the payment. So hence, you got to check or validate the incoming data and do the error handling thoroughly before you even attempt a payment through the API. And in some cases, right, your API may be dependent on another API. And there could be instances where the dependent API that you are dependent on may not be available. So in those kind of cases, you got to make sure your API does a graceful exit. And in some cases, you could have an unresponsive instance or an API, in which case you got to do a graceful degradation or graceful isolation of that instance. Okay. Particularly, you got to utilize the utility model of the cloud. You don't want to be spending huge money on as capital expenditure for infrastructure. Most of the banks these days, they have a significant cloud footprint and they have started to utilize the power of cloud. The next one would be to use the serverless solutions where you don't need to worry about the underlying infrastructure or you don't need to worry about the undifferentiated activities that goes along with a server-based infrastructure. So things like Lambda functions, which is basically a cloud function from AWS, or Aurora, RDS, these are the serverless databases, relational databases from AWS, or even serverless document DB like DynamoDB from AWS could be very helpful and when you do a serverless solution. And not to forget, API Gateway is another serverless solution for accomplishing an API-based design. Last one is test and optimize. So once you put your API in production, that's not the end of it. You always need to make sure you regularly test your APIs and make sure they are fit for purpose, they are healthy, they are secure, they perform as expected. And particularly, you've got to use the API-based metrics like performance, latency, response times, all those kind of things. And you've got to optimize your APIs. If you don't do it, then the user experience is not going to be that great. Okay. Finally, let's recap what we learned from this session. So we covered what's API. We covered what is API scaling. We covered the opportunities in scaling APIs, challenges in scaling APIs, scalability strategies, customer case studies, and best practices. And I hope the session was useful, and I'm happy to take any questions. Thank you very much.